What's up? It's Mr. J with Sci on the Fly. Why in the world is this ice cube melting so much faster than this ice cube? Stay tuned to find out. These ice melting blocks are the perfect tool to use to show your students thermodynamics in action. Thermodynamics can be defined as a branch of physical science that deals with the relationships between heat to other forms of energy, such as mechanical, electrical, or chemical energy. Now, these blocks are identical in appearance, but they're composed of completely different materials. One of these blocks seems to be even cold to the touch, while the other one appears to be warm. How much longer do you think it would take ice to melt on the cold block as compared to the warm block? The fact is that that's a very misleading question. The cold block and the warm block are the same temperature. Watch as I use this infrared thermometer to show you the degrees. We say that these blocks are in thermal equilibrium because no heat is flowing through them to another object or vice versa. Now, there are two discrepant events going on here. One, things of the same temperature can feel as though they are different temperatures. And two, the ice pieces on the two blocks melt at extremely different rates in a way that is completely unexpected. Both of these events have the same explanation. The blocks are made of two completely different materials, and they have two completely different heat conductivities. The cold block is made of aluminum, which has one of the highest heat conductivities of common materials. It feels cold because the heat from your hand, which is much warmer than room temperature, is rapidly conducted into the aluminum. This cools your hand much more than you would expect upon touching room temperature object, and your brain tells you that the object is cold. Now, the warm block is made of a rigid plastic foam. Plastic in and of itself is a very poor conductor of heat, and the air and the gas bubbles in this foam make it especially slow. Heat is conducted more slowly from your hand than experience would lead you to expect, and your brain tells you that the block is warmer than room temperature. An ice cube at the verge of melting is 0 degrees Celsius or 32 degrees Fahrenheit. Transferring the heat to the ice cube is necessary for it to melt. Both of the blocks at room temperature have the ability to conduct the heat to the ice. However, the high heat conductivity of the aluminum block allows it to conduct heat more rapidly to the ice, resulting in the rapid melting, whereas the low conductivity of the plastic causes it to melt slower. Now, as I said before, these ice melting blocks are the perfect tool to teach thermodynamics to your classroom, your club, or your group. You can purchase these melting blocks from Educational Innovations at teachersource.com. They have everything you need and more. It's been Mr. J with Sci on the Fly, the place where science makes sense.